Okay, now the question 9. Okay, question 9 is about the force elongation graph. Okay, force elongation graph. But this one is a elongation force graph. Okay, special. The elongation force graph. This is actually the E versus F graph. Instead of F versus E, this is E versus F graph of a wire as shown in the figure above. Okay, so E versus F graph. Find the force constant of the wire. So force constant is the K. And also the strain energy in the wire means the U when the force is 50 Newton or 60 Newton. Okay, first of all, we start off with finding the force constant. We have this is the EF graph. EF graph. This is the EF graph. So to find the force constant is K. Force constant K is actually the gradient of FE graph. Gradient of FE graph. That means K is F over E. Because why? Because this one comes from what? It comes from F equal to KE. So to find the K is F over E. So it's the gradient of FE graph. But we don't have FE graph, we have EF graph. So how? So very easy, very simple. This K just invert become 1 over K. So this whole thing, F over E become E over F. Isn't it? So now it becomes the gradient of E versus F graph. This is the gradient. This one become what? Become the gradient of E versus F graph. Just invert. Okay? Gradient of E versus F. So let's find out the gradient of E versus F. So to find the gradient, of course, we find the straight line. Yeah. Maybe we can take the value of we can take maybe this one. Yeah, until here. This one is 50, and this one is yeah, 1 exponent. Yeah, you see, be careful. This one is milli. So milli change. This one become exponent -3 meter. Change to SI unit. These are the things that you need to be careful. You understand? Exponent -3. So that you can find the gradient. So it's 1 exponent -3. So let's take the value. Elongation 1 exponent -3. Okay, milli. We change to SI unit meter. Divide by the force of 50 Newton. Okay, 50 Newton. Okay, so and then this is 1 over K. You get the answer for 1 over K. After that, don't forget you get the K. Don't forget to invert. Yeah, blah blah blah. Just -1. You invert. Understand? You invert the K. So after you get the value here, you become power -1. That means you invert again, and then only you get the answer for K, which is 5 exponent 4. Wish you good luck to get this answer. 5 exponent 4 Newton per meter. That's the unit for force constant. Okay, that's a unit for force constant because you know force constant is force over elongation. Elongation is meter, and also I changed from just now from millimeter to meter already. So the final answer I should get in meter. So K is Newton per meter. K is Newton per meter. Okay. So remember, you calculate this, you need to invert it back to become K. Instead of 1 over K, you get the K. Okay. That's the force constant. Now, I want to find the strain energy. In the wire, when the force is 50 Newton or 60 Newton. Now let's start off with 50 Newton. Find the strain energy in the wire. So what is actually strain energy? Strain energy is U. Okay, strain energy is area under force elongation graph. For area under force elongation graph. So that means if you have a force elongation graph, the U is actually area under the graph. If it is a force elongation graph, the strain energy is the area under the force elongation graph. But now you don't have the force elongation. You have elongation versus force. That means the area also invert. The strain energy is this area. Instead of below, it become above. Understand? With the y-axis instead of x-axis. So this is the strain energy. This is area. This is the area we need to find. So how to find this triangle? Okay. So for the first one, we are talking about 50 Newton. Okay. So for the first one, we are talking about if the force is 50 Newton, what is the strain energy? So we are taking which area? Yeah, we are taking the 50 Newton. That means it's still a proportionality limit, the limit of proportionality. So we want to find this area. This is the area we need. From here to here, we want to find this area. Come on, let's find out this area. So how to find this area? Yeah, this is the strain energy area. Okay, 50 Newton. So this triangle, we find the area of this triangle. Elongation versus force graph. So half times 50 times 1 millimeter. That's it. So U is equal to half times times what? Times this 50 Newton times 50 times 1 exponent millimeter. Need to change to meter. Exponent negative 3. So it's 1 millimeter. So it's, sorry, 1 millimeter. So 1 negative 3 meter. Change to meter already. So I calculate, I get the answer. Strain energy 0.025 joule. That's the answer. That's the strain energy if the force is 50 Newton. Okay, 0.025 joule. Now, what is the strain energy when the force is 60 Newton? So for question 2, the force increased to 60 Newton. What is the total energy, total strain energy stored in the wire? Okay, so now if increase some more to 60 Newton, just now is 50 Newton over here. Okay, I redraw here. Just now is 50 Newton. The energy U1. I got U1 just now. This is the U1. This is the U1. So the U1 I got just now is 0.025 joule. Okay. From until 50 Newton. So the area covered is this one is 0.025 joule. Now I need to find the extra area U2 because now I increase the force to 60 Newton. So I don't have this blue area. I don't have this blue area. So how to find this? This is actually the trapezium. You see that? I know it's a bit curved. It's a bit curved. But if you look closely, it doesn't matter. It doesn't matter. You can just treat it as a straight line. You know, it's a straight line. It's not so much harm, cause. It's just a straight line. So this one become a trapezium. So now I need to find U2. I already got U1. Now I need to find U2. So what is U2? U2 is the area of the trapezium. Area of the trapezium. So use your trapezium formula. Half times, what is the length? We have two sides which is parallel. So it's a 50 plus 60. This is 50 and this is 60. So it is 50 plus 60 times, how long is this? 0.5 mm. Change to SI unit. Yeah, don't forget this is mm. You change to meter instead of millimeter. Change to meter. So how long is this? 0.5. This is only 0.5 mm. So milli is -3. Change to meter. So what's the U2, the area of trapezium I get? It is 0.0275 joule. That's the U2. That's a U2. So what is the total energy when 60 Newton force? What's the total energy stored in the wire? It is U1 plus U2. So the total energy stored is U1 plus U2, which is equal to 0.025. Yeah, just now U1 50 Newton is 0.025. Is it 0.025? Now plus with this U2, the trapezium one, 275. So what I get? I get 0.0525 joule. That's the total energy stored. Total energy stored in the wire. Okay? Understand? Yeah, very simple, isn't it? Yeah. So okay, this is the elongation force graph. So remember to find the force constant. Force constant is gradient of force elongation graph. But if you want to get the elongation force, you need to invert K, become 1 over K. So this one become E over F. And then only become gradient of EF graph. And then if you want to find back the force constant, don't forget to revert back, inverse back. Then you only get this answer, force constant. And for strain energy is the area under the force elongation graph. So instead of this one, you get this one for elongation force graph. Okay? And sometimes you need to use trapezium formula. Okay, see you in the next question. Thank you.